If you have not already done so, get the Chapter 7 packet from the back while he's blabbing. I got a little trigger happy with all of the deleting of videos from old semesters and accidentally deleted every version of the 7-1A video. So business as usual today. I think so. I've got the rest of the chapter. And honestly, I just got too much work to do, so I might set you loose on videos while I... Well, no, I just have work to do. Like, I'm putting in headphones and telling everyone to leave me alone. If you are done with Chapter 4 packet and want to start a new pile, go for it. Super staple.
Can I have a super stapler? I need to staple this paper. Well, you really trust me to use this? I'm scared. How do I do this?
Republic, one nation, under God, indivisible. Have a great day.
Oh, I'm so scared.
Okay.
This is so fun.
Couple housekeeping items. If you did not hear me say it already, A, I just don't have a 7-1A video. I accidentally deleted all of them because I was going back and deleting like old semesters of stuff. And I had planned for all week long, you just roll through the videos so I can get work done. I am behind about 6 weeks worth of grading because things have been that rough. Case in point, I was up 4 times before 1:30 last night, and then I kind of intermittently slept on the floor for another 3 hours. So it's been a journey, and because of that, I don't have a lot of grading done. I need to get caught up on that. So I haven't heard anyone complain too much about the videos. It's just watch class, right? So if y'all are okay with that, help me out a lot if through Chapter 7 we could just, y'all go watch videos from, it's either last semester or last spring, I don't remember which, and it's the same stuff, okay? So you just go through that. You'll hear me maybe grumbling about, instead of 3 leeches, be grumbling about the 4 stooges up front. But the same thing, right? We had a crew in there. God, what was that? It was like Donald, Rylan, Gibbs, like, yeah. Like, it was a good one. I mean, they're all great guys, just they're goobers. Sound familiar? I mean, I kind of averted my gaze over the no. So, everyone's got the Chapter 7 packet. We're going to get through as much of 7-1 as we can today. I also have the review for the final. If you choose to, we are not going to have time in class for any in-class review for the final. What you get for the final is this, and whatever you can write on it. It is not open everything. It is whatever you can write on this. The problems look exactly the same. I've talked about it from the beginning of the semester onward. It is going to be 5 multiple choice questions, or it's going to be 5 choices on multiple choice questions. 1 point for reasonable work shown, 2 for the correct answer. That's it. Of those multiple choice, anyone who has not taken a good multiple choice test before, if someone gets excited when they hear multiple choice, it's because they're used to things like, who was the 28th president of the United States, and option C is Kermit the Frog, and option D is the teacher of the class. Like, that's not a multiple choice test, okay? This is I will intentionally miss a negative and run it all the way to the end zone. I will intentionally square like a freshman and run it all the way to the end zone. I will do the things that students normally goof, and those will be the other answers. Because that's how it's done with ACT. Okay? I despise standardized testing because of how biased it is, but if you're going to play the game, you're going to play it well. Okay? So the review, the key is online. You just go into our shared folder. But if you want this, I'm just leaving it on the counter. It's up to you how early you want to attack that. The second I set it down. Okay? It's up to you. You get that, and whatever you can write on it, it will be the exact same type of problem, just like our reviews and quizzes normally. Okay? Now, I said the same type. So for example, if number 19 is, tell me which of these is a maximum of this sine function. Number 19 on your test might be, which of these is an x-intercept of this cosine function? Okay? It's going to be something very similar, not necessarily identical. I will just throw up a little tally over on the sideboard here now that we're close to the end, that you can vote if you want the 2-day final, more wiggle room in case you get stuff wrong, 2 days, 20 questions each, or if you want to go 1 day, pick your day final, 20 questions, less wiggle room, but it's only 1 day. I will put the voting tally up there on the board up behind Riley's head and let you all decide. So far, no class has chosen 2 days, but I will give you the option because I want you to, as a class, decide. Okay? We are in here every day, so technically we're supposed to be in here for 2 days of finals. If you choose as a class to only do the 1, cool. I'll just pick the 20 most relevant questions off of our review. And they'll be numbered the same way. So if I did that, the final would go like 2, 3, 7, 9. It would still match with those problems on the review. Okay? I wouldn't be looking for you. You would pick which of those 2 days you show up.
Yeah. Do we have duct tape? Do you need a marker? I have.
What did you do? I said a number.
Very.
Y'all ever seen Chronicles of Riddick?
Why do you always say that number?
Okay, there's a point where he's in prison and he's like doing Vin Diesel, I'm a big badass kind of thing. He sets a teacup down on a rock and says, I'm going to kill you with my teacup.
Can I kill him with that marker?
No, I'm just saying, I got a marker. I got a marker and I'm not afraid to use it. Okay? All right. So, chapter 7, here we go. All right, game time. Chapter 7 is about conic sections. You may have heard me say that before. Conic sections, you've kind of talked about them before in other classes. But the idea is if you have 2 end-to-end cones and you put a plane, remember a plane is 2 dimensions, right? X and Y axes. If you put a plane, a slice of paper, through those cones at different angles, these are the types of figures that would be created. That's why they're called conic sections, a section of a cone. Okay? If the plane intersects it perfectly perpendicular, you get a circle. You derived how to make this in geometry. Because remember, in that circle, Frank, wake up. Okay, remember, I may have this radius, but if I turn that radius into a triangle, right, I'm going to have this idea of horizontal and vertical movement as I rotate it around. So, get rid of you. This triangle has coordinates x and y. But then this triangle also has coordinates x and y. Do you remember how we differentiate between them? Okay. Oh, we could use primes, but what if I've got 15 of them? That'd get kind of sloppy, right? Remember doing this? The subscripts? Oh, that's supposed to be a 2. You did this with lines. Remember slope? Y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Okay? Well, if I do that all the way around, then those distances are going to be y2 minus y1, where this is 0. This would be x2 minus x1. Okay, we're ignoring this now. Those distances can be shown by subtraction. And then if I do Pythagorean theorem to find the radius, it's, remember distance formula was x2 minus x1 squared plus y2 minus y1 squared. Distance formula is just Pythagorean theorem. Well, if I do an infinite set of Pythagorean theorems, I get, whoop. Oh, now you're going to combine them? You know, some days, Frank, just put a chair through your face. I can set that equal to r squared, and it becomes an equation of a circle. Okay? Well, they took that idea and started tilting it. They started saying, well, what happens if I tilt that plane a little bit? Well, now I get an ellipse. Don't call it an oval. Okay? We're not in elementary school. It's an ellipse. An ellipse is just an elongated version of a circle, so I'm going to change the formula to reflect that. A parabola is when it goes infinitely, right? The parabola is going to keep headed out this way, but it's going to keep headed out this way such that it's always within the cone. So it goes on infinitely, instead of being terminal sides like a circle or an ellipse. And then, if I take that ellipse and explode it outwards, I get what looks like double end-to-end parabolas, a hyperbola. Okay? And I honestly believe that of this week, of these conic sections that we're going to do, parabolas are the toughest. Ellipses and hyperbolas are not that big a deal until you start rotating them. For that, you're going to go to trig. Okay? Because when you rotate them, now all the coordinates, that nice little 5, 3 up here is now going to be 5 cosine of theta, 3 cosine theta, because it rotates. Okay? So, these are all different types of conic sections. We're going to start with parabolas. Parabolas, it turns out, there's stuff that we didn't tell you when you were younger. There's other stuff about parabolas that we never told you. Now it also depends on your instruction. It depends on where you came from. I know in this school, we do not talk about the focus and the directrix. We do not talk about the latus rectum. We do not talk about all kinds of stuff. We just say, here's an axis of symmetry, here's a vertex, done. Okay? There's a lot of other stuff. Additionally, we get the official definition of what a parabola is. A parabola is a locus of all points. Locus just means set or group. A locus of all points such that the distance from a focus to that point is the same as that point to a directrix. You're like, okay, you just use like 3 new vocabulary terms, and I don't know what those are. Okay, so you all know the axis symmetry, right? Goes through the vertex. It reflects across the axis symmetry. Well, there is another point besides the vertex called the focus. A focal point. And you've seen this in the real world. Anyone have a satellite dish on their house? Okay. You at least know what it looks like, right? Okay. A satellite dish has this receiver out here. And that receiver is at the focal point of the parabola that the dish makes, where beaming lasers from outer space will hit the parabola and bounce off to the focal point. But if the satellite is over here, it'll bounce off of here and go to the focal point. But if that satellite moves over here, it'll bounce off of here and go to that focal point. Okay? That's what a focus is in a parabola. It's the point where this point right here is the same distance to the focus as it is to a directrix. And directrix is another line like axis of symmetry that is important to the features of a parabola. It's super easy to find these 2 points because we're getting a new version of the equation for parabolas. You're used to this. Y equals A times x minus h squared plus k. Right? Remember vertex form? You better, because you've been doing that since Algebra 1. And I am not rehashing Algebra 1 in PreCalc. Okay. Easy peasy. If I want this by itself, I'm going to subtract k. And then I'm going to divide by that a, which means this has to go in parentheses. I put 1 over a here. And this creates a new version of the equation. Okay? And that 1 over a is going to get a makeover. It's got a new name. Now it's going to be x minus h squared is 4p. Y minus k, or y minus k squared is 4p by x minus h. Okay, so that 1 over a, I'm going to give it a makeover. I'm going to call it the 4p value. So y'all remember vertex form, right? I rearrange vertex form, I get these. What's the difference between those two, though? The purple ones. Whether x or y is squared. These are going to be called conic sections, not conic functions, because we are going to leave the realm of functions and go into just relations now. This parabola is not a function. It fails vertical line test. Doesn't mean I can't graph it. Too bad. Okay, so I'm going to get different versions of this, and they are going to determine whether we're going left or right. I'm going to come back to this page, but it's just these. Okay? New features. Okay, so next to this, I'm still going to have a vertex. Oh, I said vertex. Whoop. My vertex is still at HK, regardless of whether this is opening up, down, right, or left. I said finding that focal point and finding that directrix are really easy. The reason that this is 4p, remember that 4p was my 1 over a value when I rearranged. You're going to p in both directions. You're going to move p units this way to find the focus, and you're going to p units this way to find the directrix. Okay? Everyone in the room imagining being water benders right now. Okay? Okay? So, literally, I'm just going to go p units in this direction, this direction. Okay? So here's example. This one right here. Let's say this is at x minus 4 squared is 1 y plus 2, like that. Okay? So it's super, super simple. Can you identify what h and k are? Do you recognize h and k on here? Bass-Ackwards land, Bass-Ackwards land. What are we looking for? Oh, okay. I still got my vertex at HK. This is in the 4p spot, so p is 1/4. That means from my vertex, I'm going to go a 1/4 unit this way and a 1/4 unit this way to find my focus and my directrix. Like, that's it. This is in the 4p spot, so I will go 1/4 of a unit in both directions to find those features. That's it. After that, if you remember your perfect square steps, these become very simple. Okay? I want you to look at the sideways one. Look at what's different.
Shut up.
I'm 3 seconds. I'm like 3, like, more. Looks like it's
I wonder if I have a dry erase marker on that.
Please go away.
Smack him.
I don't.
Smack him.
No, I do not.
I shouldn't have brought
When you feel it, look at his face. It's a very punchable face.
Go at it.
Lori has a sword. I do, and well, not on the.
You have a sword on you?
Oh my God.
Shot.
Oh.
Your shots are both actually stupid.
You guys have been in a certain position for everybody. The greater.
Shot.
I'm starting a body shaming for everybody to come forward
Like to
and say how you guys strong heads for your yourselves. I know.
Would you like to do some fencing?
How do you think you do? Huh?
I'm done.
How do you do some fun? You have you watched the
I'm taking the 0.
Because there's that exact joke American meme. Remember how you went?
Have you seen Spaceballs?
Oh,
You seen Spaceballs? Yeah, it's like in that.
Oh
Where it like zooms down.
And then my dentist says,
It's like a family guy skit where Herbert is like, and he sees Granny.
like, you don't snap. I'll show you, I got you.
Hey, Kate, like
I've
my
never
shoes?
heard of it. You're wearing your grandpa shoes.
Yeah, buddy. Okay.
All right. Sorry about that. Someone made bad decisions. So, if I switch over, absolutely. If I switch over to these, you see the only difference is what's squared, right? Y is squared now, so it's going to be tipped on its side. Just like when we talked about, remember y equals square root of x, we didn't do plus or minus because it would have created exactly this. It wouldn't have passed a vertical line test. We're still going to graph them. I know this isn't a function, I can still work with it. Okay? But you're still going to put your vertex at HK, and whatever number is here, like say it was 8, then that means P is 2. I go 2 units in this direction for my focus. I go 2 units in this direction for my directrix. Okay, easy peasy. You're still going to do your perfect square steps. Remember all those to make parabolas? I hope. From the vertex, up 1 over 1, up 2 over 4, up 3 over 9, up 4 over 16, and so on. But we're also going to start doing compressions and stretches with those that involve some fraction stuff. Okay? So, that's the gist of parabolas, is they got a couple of new features that we're not used to. Those features can be written out algebraically. I know this looks like alphabet soup, but break it down right here. The vertex is HK. The focus, I add P in this direction. I subtract P in this direction. Those get me the focus and the directrix. Okay, that's all these say. So it's not a big deal. Also, by definition, if I go from that focus to this point, it's the same distance as that point back to my directrix. No matter where I am on the problem, we're going to use that information too. But we have to start by, can you even graph the thing? So, I'm going to write that again. Y plus 5 squared is, just so I can make the graph a little bigger. Whoop. There we go. Okay. So I start by saying, where is my vertex? HK. No. H then K. No. H then K. All right. Listen. Instead of just like yelling it louder, mansplaining to the class, okay? 2 then negative 5. H goes with X, K goes with Y. Even if the parabola gets flipped on its side. They're still grouped in parentheses, they're still in bass-ackwards land. So I go make a dot. 2, negative 5. 1, 2, 3, 4, 5. Oh, 1, 2, 3, 4, 5. I can swear. I can swear. I swear I can count. There. Y'all. Oh, I can swear. You hear me outside of contract hours. My vocabulary has significantly deteriorated in the last few months. Is this going to go to the right, go to the left, go up, or go down? How about this? Do I know if it's up, down, or left, right based on the equation? Is it vertical or horizontally opening? That depends on what is squared. The y is squared. If the y is squared, that tells me that it's going to open left or right. And the 4p value is what tells me if it's negative or positive. Where are the negatives as I'm looking horizontally? Are negatives this way or this way, right? So because the y is squared and there's a negative, it tells me it opens this way. Y is squared means it's sideways. Negative 4p value means it's going to open to the left instead of the right. Okay. Next up, axis of symmetry. My axis of symmetry is always a line that goes through the vertex. Since I know this thing opens sideways, I can draw my axis symmetry right there. What is the equation of that line? Y equals -5. Because x equals is vertical lines, y equals is horizontal lines. This is why, since you've been doing parabolas from Algebra 1 onward, your teacher should have been telling you over and over, you can't just say axis of symmetry equals 2. X equals 2. Because the line matters. I'm going to say my axis symmetry is y equals -5. My focus is completely lost, but on here. Remember, this is my 4p value. If 4p is -12, then p is -3. So I'm going to p 3 units in this direction. For a focus at -1, -5. And then directrix, I'm going to go 3 units in the other direction. And if my axis symmetry is horizontal, means my directrix is going to be perpendicular. So I go back 1, 2, 3 units, and then that's my directrix. And I say it with the equation. Don't just say a number, because it's a vertical line. This is x equals 5. Okay. All that's left is to fill out the shape of this with the correct stretch or compression. Remember, well, Frank's a little cross-eyed here and I'm terrified to mess with it. Remember that this 4p value was also 1 over a. So if -12 is 1 over a, swap my extremes or cross multiply solve, whatever your jam is, a is -1/12. That means it's a compression by 1/12. So you're going to take all your perfect square steps that you're used to, right? 1, 1, 2, 4, 3, 9. You're going to take all of those and you're going to take the squared number and times 1/12. Remember I said you got to be able to fraction here. So normally, this is not the graph, okay? This is not the graph. I would go 1, 1, 2, 4, 3, 9, and so on to make a parabola. This is not the graph. This is not the graph. This is not the graph. Okay, so normally this is what I would see. I'm going to have a 1/12 compression to that. And because y was squared, it is a horizontal compression by 1/12. Okay? So take all of those same values and times 1/12. Up 1 and over a 12. up to and over 4/12. A third. Up 3 and over 9/12. 3/4. Up 4 and over 16/12. 1 1/3. Up 5 and over 25/12, which is just a hair over 2. You see that so far these are all nasty fractions. But look at what happens at 6. Up 6 over 36/12. It's just a nice 3, isn't it? Why is that? Why were these all nasty fractions, but that one was go up 6 over 3? $36 was divisible by 12. Okay? My perfect square steps that are divisible by 12 are going to be nice numbers. So I'll just make that one a little bigger so we remember. I'm going to keep going just so you see how this works. 7/49/12. So 4 and some change. Up 8 over 64/12. 5 1/3. Up 9 over 81/12. Just a hair under 7. Up 10 over 100/12. Just a little bit over 8. 11, 121/12. 12, 144/12. So just go 12. 5, 6. So what I would like you to do as you're making these parabolas is, yeah, you can do all the little fractional bits, but if I have a compression of 1/12, use perfect squares that are divisible by 12. Did I miscount? Oh, because I missed the next point. Yeah. Is it 2 to there? Okay. It looks like you've derailed this conversation so many times that we're going to debate which of us is getting brownie points. It's probably going to be both. Good talk. So, okay. What I'm saying here is you don't need to do all the points because some of them are going to be nasty with our new parabolas. But if you go up 6 and over 3, because 6 squared is 36, 36 is divisible by 12, I would just use those points, okay? So, step 1. Identify, does this open up, down, right, or left, based on what is squared and whether it's positive or negative. Step 2. Find your vertex, HK. Step 3, axis symmetry. Step 4, P in both directions for your focus and your directrix. Step 5, whatever that 4P value is, 1 over that is your compression or stretch. Go find some other dots so you can get the right shape to it. And we have to be able to do this before moving on to the next thing, because in the next thing, remember when I said you do have to know how to complete the square? We there. Okay. So, 1A, I'll tell you right now, it's kind of right. They just wrote it backwards. What if I switch that to x minus 4 squared is 8 by y plus 3? See, now it looks like the other one did. Okay? Go find HK. Go P in whatever directions. Okay? Remember, they're grouped in parentheses, so it's bass-ackwards land. Just start with 1A. I know Heidi was, no, she's here today. It was Chad and it was just Spear that went with the math kids for the competition, right? Okay. I know Holly went to the competition. Pretty sure Owen did. What about the other two, Maddie and Isabella? They're both at the competition? Okay. Because I didn't get an email list for who all was going. So we'll give them benefit of the doubt for now.
Just watch what he does. I don't know if he's right or wrong.
Okay, if x is squared and there's a positive 4p value, we're headed up. Okay, x is squared means vertical. Think along the line, x equals number. Positive means it opens towards the positive part of that axis. My axis of symmetry would be x equals 4 because it goes through that vertex. And then if 4p is 8, then p is 2. That tells you how far you're going towards the focus and towards the directrix. The focus, since it opens upward, focus goes over here. Actually, it's a good idea to label these points. At the very least, label them like that and then have your coordinates off to the side. Again, I know some of us hate drawing or writing on our graph, So at least label them like that, and then off to the side tell me what they are. I'm going to have my focus is 2 units north of this. I have a focus at 4, -1. Okay, I can label it on the graph, or I can label it over here. I don't care, as long as anyone can pick up your paper and tell what's going on. My directrix, if I go to north for that focus, I'll go to south for directrix. And we'll write, what is the equation of that line? Okay, y equals, because it's horizontal, and if it's 2 down from -3, yep, y equals -5. And then, remember that if 4p is 1 over a, then a is 1 over 4p. That means a is 1 over 8. I'm going to have a 1/8 compression to all of my perfect square values. I could fill in with all of my fraction values, and there's nothing wrong with that. But it's easier if I use values that are divisible by 8. So what's a perfect square that's divisible by 8? 16. So from the vertex, I'll go over 4 and up 16/8. Back 4, 16/8. What's another one? Not until 64, right? I would go over 8 and up 64/8. So over 8, up 8. Here's 4, 5, 6, 7, 8. Here's 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. There we go. So if I use those perfect square values, where I'm going over 4 up 4 squared, but dividing it by 8. I'm going over 8, going up 64, dividing it by 8. I don't have to find all of the points. I can just find ones that are nice, because I'm still going to see enough to get the curvature of this parabola. Okay, I connect dots. As long as it stays curvy, we good. Okay? You don't have to find all of those points. You're going to be more accurate if you do, but just find nice ones. Okay? I went to the ends of the graph. You should always make your graphs to the end of the graph. From here, I go over 8 and up 8. 1, 2, 3, 4, 5, 6, 7, 8. Up 8. Be like Vanellope floating off in the distance there. Okay? It's not the point 8, 8. It's 8 horizontal and vertical motion from the vertex. Okay, so we've seen it twice. Can you, it doesn't need to be rearranged much, only a little bit, because they wrote them on the wrong sides. Okay, rearrange this to normal. This is called the standard form. Put it in its standard form, and then, can you graph it? Which way does it open? What's your vertex? H and K. P in both directions. Find your vertices, or your focus and your directrix. Tell you this time you're going to have fractions. Yes. Anyone else notice that the wind shifted so it smells like cow pie in here? Like wind is coming out of northeast today, so it smells like cow pie in most of the schools that have direct line ventilation. Fertilizer.
On what? How did you get this point?
That's -6, 1.
No, it's not.
-6, -1.
Oh,
-6.
Special.
-6.
Oh, Sammy is not smart sometimes.
Check the beginning. Y is squared with a positive 4p value. Did you have it opening the right direction? Did you have the correct vertex? HK, bass-ackwards land.
Yeah, because that one's going up, so you go to the side. You can go sideways.
Why can't they just all go the same way?
Because we're just one.
Child, given your personality and neurotype, you should not be advocating for conformity.
Your personality. My personality is great.
I have so many memes for this right now.
It's 11.5, Lori.
It's -11 halves.
No, this is right there. Lori, that was 5.5. Yeah, 5 halves is 11, or 5.5 is 11 halves. No, it's not.
Sorry.
5 halves.
-11 halves.
I mean, that's the same. I don't even know what that is.
5 times 2 is
10, and then plus 1.
Okay. So this one's got itty bitty little space. My kid watched it this weekend.
I watched it Saturday.
Yeah.
Aladdin!
Original Aladdin, the one with all the racist connotations in it. But it's got Robin Williams, so. No, it's not. It's just what I grew up on. If you actually watch Aladdin on Disney Plus now, it does have a disclaimer at the beginning of it because of that. Good. Peter Pan is horrible. Yeah. Yep. Yep.
See, they don't do that anymore, they do like
Just straight up. I didn't even notice. Until like, it's been years since I've seen them.
Okay, so we're only going to go 1/2 a unit in both directions for our directrix and our focus. That directrix is back just a 1/2 unit, 6.5, or x equals -13 halves. Okay, so not much movement here. It also means that it's going to be really easy to do my perfect squares this time. Because if 4p is 2, then my compression is 1/2. It's only a compression of 1/2. Take your perfect square steps and cut them in half. From the vertex, up 1 over 1/2, up 2 over 4 halves, up 3 over 9 halves, up 4 over 16 halves. Now again, you don't have to do the fractional parts. You can just take ones that are even because they're divisible by 2, make life a little bit easier. I would go up 6 and over 36 halves, or 18 units. So what's that? There's 16, 17, 18. We're already off-road. Connect the dots, or not connect the dots, mirror the dots. There you go. Words are hard. Connect the dots. Now, try to keep it curvy. Okay? Are we doing okay with those perfect square steps on the side? Because I know some of us, when we came into PreCalc, had just never heard of that, which terrified me. Okay, those perfect square steps that make parabolas, instead of just doing it by table every time. Usually what happens with these is kids are just fine with the first 4 bits of information there. It's doing the compression and getting other points. They just don't like it because it has fractions. Okay. What if what if it just did this? I changed the equation at the top. Now where's my vertex? Where's my vertex? It's still at -6, -1. See how there's no parentheses? There's no parentheses because the value in the 4p spot is what? 1. So that means you would have a 1/4 value for p. Okay? Now, you notice a quiz or two ago I said you have to solve this thing by factor and complete the square? Y'all did solid on it. The reason for that is sometimes it don't look the way you want it to. Sometimes it's all spread out like this, or worse yet, it's in general form. But do you recognize that this is a perfect square trinomial? This is what squared? Y plus 3 squared. This does not look like 4p times x minus h. What do I do to make it look that way? It needs to say x minus h. I need to have x by itself. So whatever the coefficient of x is, regardless if it results in a fraction in those parentheses, you just factor it out. Which would mean this is now -1. You'd be okay with it then? All right, so as we move forward, we're going to get some of these where you got to do some work to make it look right before you can finish it off. All right, we seem to be okay with the mechanics of it though. Oh no, words! Like I was trying to tell you. We're a little bit squirrely on a Monday. Parabolas are naturally, or not naturally, parabolas are things that we use in science and technology an awful lot because of that focal point. Have you ever seen a movie or even watching like sporting events, like watch a football game? Do you ever see someone with the shotgun mic? Like, it looks like a tiny little radar dish in their hand, and they got the big headphones and they're aiming it at people. That's because the sound waves from something 90 yards away, that tiny little wave hitting this tiny little dish, reflected into that focal point, because it focuses the waves, you're able to amplify that one spot. That's how you're able to use one of those tiny little radar dishes to hear someone like a quarter mile away, their conversation as if they were standing right next to you. You ever watch like a pro football or basketball game and never notice that the coach will put they'll put their little play sheet in front of their mouth? It's because it blocks that. It'll block the sound waves being read by shotgun mics. It'll also block lip readers. Like, that used to be a thing. People would have a guy up in the booth, like aiming this little microphone at the other coaches, and they would have someone who knows how to read lips just telling their team, oh, hey, they're going to run right this time. Like,
going right, you guys.
Okay. Very famously, gone now, but Kobe Bryant he was a polyglot. He could speak multiple languages, and he would intentionally learn how to insult people in their native languages, so he could trash talk on the court in like some Scandinavian language. And he was fluent too. Like, that's next level trash talk. Mm-hmm. Yeah, and go ahead and listen to good old Ballad of Ira Hayes to figure out how that went afterwards. Wind Talkers, yeah.
Literal whole movie about it. It's a good movie.
Yes.
10 out of 10.
My brain was blank.
So anyway, those are applications of this. They're going to say, blah, 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 here's a mirror, trough mirror that is in the shape of a parabola. These are types of solar collectors where it's inefficient to just have one big honking rectangular panel just sitting out there. What you do is focus it. Everyone ever done the magnifying lens trick? Starting fires with it? Okay. It's got a focal point that's back-to-back ellipses. It's actually called an obloid. You use it to create a focal point. Well, what happens if I take all of that light and I don't want any of it bouncing off out over here? I'm going to put my collector in the middle of it at the focal point. Then I will always have the maximum amount of energy collected. They say the cross-section of it is this equation. So parabola, x squared equals 3.04 y. And they're going to say, where is the receiver? Well, if the receiver is at the focal point, and I'm treating my vertex as 0, 0, see how it's x minus 0 squared? And y minus 0 here? They just simplified it. They're asking, where is that receiver? Where is that focal point? So the only other number I have in there is 3.04. Which spot is it in? For our equation, what spot is 3.04 in? It's in the 4p area. So they're just straight up telling me that 4p is 3.04, and don't we p in this direction to find that focal point? So p is divided by 4, 0.76. 0.76 what? Read problem, context. 0.76 chalupas, 0.76 shrunken heads, meters, okay? And if it's 0.76 meters, y'all remember your conversion factor, how many centimeters in a meter? So I could also call that 76 centimeters above the trough. You could go kilometers, you can go down to millimeters, you can do whatever your jam is. Nice thing about metric is it's very easy to convert. Okay, now if you want to say that an inch is approximately 2.54 centimeters and go all the way into miles, go for it. You did that back in physical science. Okay. See, I was with you up until that last part. That's too far. That's so random. It's like the I hope you step on a Lego. Do the other one. Rachel, please do the problem.
This one has way more numbers.
Means you have to write it in the correct form.
But what is this 5 thing?
They're saying from x is -5 to x is 5 because does it make sense for this parabola to extend infinitely wide?
Did you seriously just No, I know what it is now.
They're saying that the telescope's only 10 feet wide.
It's okay. So I draw a telescope?
No, you draw a parabola.
That's 10 feet wide. You need to add that.
You just got science.
Oh, look at the telescope. Oh, usually crazy. Why can't they just do something easy?
No. Ah.
This is from a while ago. I don't know if I want you to see this.
Put it in standard form. All these are is just a word problem saying, do you understand that the focus is this distance from the vertex?
Oh my gosh, no, you missed.
Okay, so that -5 to 5 for x's, what they're saying is it doesn't make sense for this parabolic object to go on forever. So it cuts it off there and there. Okay? You factor. Factor, friggin' factor. I want that y by itself. The 44.8 comes out. And I think that's just 6. Right? 40, 240, 24, 64, 875. Yeah, should be 6. So since this is my 4p value, then that tells me that p is 11.2, and they're talking about feet. They're saying that this focal point is 11.2 feet above my vertex. That's it. That's all it's doing. Okay? Now, complete the square. We've done it many a time.
Okay.
Okay. All the way back in Algebra 1, we tried showing you complete the square to get vertex form. Y'all didn't like it. Too bad. We were showing you for a reason. All this conic section stuff we're doing this week, technically it's supposed to be in Algebra 2. Okay? So, to complete a square, first things first, I'm going to put, what is the variable that's squared? I want to put that stuff on one side. Okay? So negative 1/4 x squared plus 3x is going over here. I'm going to put not x stuff on the other side. Okay, so I just subtracted 6 to the other side, flipped them around so that it looks the way I want it to. At the end of this, I need this to look like x minus h squared is 4p by y minus k. Notice that it's always x minus h. When we did complete the square, we always said variables over here, constants over there, and then divide by a. A screws with everything. Right now, what is a? What is the thing in front of x squared? Coefficient. So if I have a negative 1/4 in front of x squared, I need to eliminate the Canadians, divide everything by a. When I divide by a negative 1/4, I'm really multiplying by a negative 4, getting x squared minus 12x is negative 4y plus 24. Do you remember how we completed the square? What was the perfect number that always gets added in? b over 2, the quantity squared. So, half of negative 12 is negative 6. Negative 6 squared is 36. So add 36. Now I can write it as, come on you. This is x minus 6, the quantity squared, it's always half of this guy, is a negative 4y plus 60. Still don't quite look right. Don't do square root. I want this squared. That's the form. I factor out on the other side, so I have a y minus k. I have to get rid of the coefficient of y. putting -4 out here, dividing by -4, getting -15. Now I'm in business. But I have to complete the square first. Now, here, let's start with okay. Then we're going to sketch. I say go away. Whoop. Okay, notice there isn't any graph spot on there. I want you to be able to sketch these without having to rely on a graph to count out boxes. We have to understand what the relationship is between these distances. Is this going to open vertically or horizontally? Vertically, because x is squared. Will it go up or down? I heard both. How do I tell the difference? Negative for p-value. So we're going to head towards the negatives on that axis. So draw a generic parabola headed downward. On it, label a vertex, label a axis of symmetry, it may not be drawn to scale, that's okay. Label a focus, label a directrix about the same distance back from the vertex. And just to make sure that we have the correct stretch or compression to it, let's label some points out here and now it's time to fill stuff in. Like this is just, it goes downward. Okay? That's just generic, it goes downward. Or it opens downward. Where is the vertex? Okay. 615. What is my 4p value right now? So p is -1. Go 1 below it for the focus. So am I subtracting 1 from the 6 or the 15? Because kids will get this wrong. Okay. Down to 6, 14. Notice how both of those, scrunched eyebrows of doom. Notice how both the focus and the directrix are on, the focus and the vertex are on my axis symmetry. Look at what number they have in common. So that means my axis of symmetry is x equals 6, the vertical line that goes through them. So that means my directrix must be perpendicular, or y equals, I'm going to go 1 north of the vertex. Yeah. I'm just wondering how many of us are actually picking up any of this because we're just distracted. Also, if 4p is -4, that also means that a is 1 over -4. I'm going to have a 1/4 compression. So to find those points, I'm going to use perfect squares, like over 1 down 1/4, over 2 down just 1. So I could, from my vertex, go over 2 down 1 and put a point right here. That is over 2 down 1. Over 2 down 1. Or keep doing things that are divisible by 4, or perfect squares divisible by 4. I could go over 4 and down, not 16, 4. Over 4, 10, down 4, 11. Over 4, down 4. We should be able to sketch that and label this without the graph to guide us if we need to. If you need the grid there to guide you, then just grab some scratch paper. Grab some graph paper, okay? But if I had that on a piece of paper, would you be able to understand what's going on? Okay, because everything is labeled accordingly. So you have to complete the square and then go do all the stuff. So they're going to start very easy, very nice with you. Go. Baby steps. No. Yes. Okay, no square completing necessary this time because x squared is already a completed square. This is the simplified version of it. If you need to write this to wrap your head around it, you go right ahead. Just know that this is the real answer. Okay? So does this open up, down, right, or left? X is squared, vertical, positive 4 p-value, up. All right, where's my vertex? 0, -1. If the 4p value is 4, means p equals 1. So I only got to go 1 north and south of this for my relevant features. We're going to have a focus at 0, 0. Going to have a directrix down at y equals -2. X equals 0 for a axis symmetry. And for my side values, we have A is 1 over 4. So we're going to use perfect squares, but cut them in a quarter. Easiest way to do that is 2, 4. 4, 16. 8, 64. 6, 36. Right? Use things that are divisible by 4. So from that vertex, I'm going to go over 2 and up 1. I'm going to go over 2 and up 1. If I go over 2 and up 4 normally, take that times 1/4.
Yeah, I was doing 4s on my paper, but I wrote a 2 instead of a 4, and then I was confused because I had the number 3. So it's going to be 4 up 3, and
Yep.
I wrote 2.
It happens. I can go over 4 up 4. So this will be at 4, 3. That's probably where the other 3 came in. And back at negative 4, 3. Okay. So this one was nice in that I didn't really have to complete the square. I just had to rearrange a little bit of stuff. Am I okay for round 2? Go. Now we got to complete some squares. Get it in standard form. Um, 3, 5, 6, 5, 4, 6, 5, negative 15. B 1, 2, 6, 5, 1 plus 1 equals 15. So it's going to divide by 3, 4, 4, 5, 1, 2, 5, 4. No.
I just did something like that.
Right? It's negative 15 divided by 5 is negative 5. Plus 1 is negative 4. So, yeah. I'm pretty sure. Yeah. Yeah, keep going.
Oh, okay.
Complete the square, then factor out the 4.
Oh, so then that's like all the way to, okay.
Yep.
I just wanted to make sure that I was doing it.
Yep, complete the square, then factor out the 4. How'd we do on the complete square part? Okay. Then, open up, down, right, or left. Y is squared, positive 4p value, we had it right. So I make generic rightward parabola. Vertex is still HK, be careful that H still goes with X. So my vertex is at 1, -1, not the other way around. If 4p is 4, then I'm going to 1 in this direction and 1 in that direction.
Any of the following students to the office: Brody Petro, Kenneth Hampton, Ava Sprague, McKenna Cranbeck, Jericho Monaco, Charlie Rasmussen, Finley Worthington, Corey Cook.
And you got a 1/4 compression again. So over 2, or up to over 1. So 1, 1, 2, yep.
William Potrak, please come to the office.
There you go. Yeah, that's about right.